Hi everyone, I want to talk a little bit about methods of solving a system of equations. Okay. First I'm going to start with some substitution. So now substitution works pretty well on smaller systems of equations. So for example, we have this one is two equations with two unknown variables. So I've just named them equation 1 and equation 2. When doing substitution, you want to look for something that's the easiest to solve. So in this case, both x and y in equation 2 are a little easier because they already have, positive 1 quantity. So I'm going to pick x to solve for. Okay. So I'm going to use equation 2. I'm going to solve for x. So now my equation I'm starting with is x plus y equals 3. And if solving for x means I want to get it to be an x equals. So in this particular case, I just need to subtract y. So I have 3 minus y. Now I am done temporarily with equation 2. So I'm going to go to equation 1. And I'm going to write down what I know. So I have 2 times x, but x is 3 minus y plus 3y equals 11. Okay, and then I need to distribute that 2, so I get 6 minus 2y plus 3y equals 11. Then I would need to combine like terms. I have 2y to the first powers, so I get 6 plus y equals 11. And lastly, I'm going to subtract 6 from each side. So I get y equals 5. So now great, we have one of our unknown variables solved for. However, we need both. But if we know y, right, we just made an equation to solve x. So this is x equals this equation. So I'm going to plug y into there. So x equals 3 minus 5, because that's what y was, and that is negative 2. Now we have one more step for a system of equations on how to write the solution. So now when we're solving a system of equations, we're looking for, are there any points of intersection? Which means I need to write a point as my answer. So in this case, it intersects at the point negative 2, 5. Okay, that is the only point where those two lines will cross.